Welcome to Tech Hook. If you are new to this channel and you love consuming content on space exploration and technology, then you know what to do. Hit that subscribe button. Now if you've done that, let's go ahead and head on to our video. In today's video, we will explain everything there is to know about collision between two supermassive black holes. Are you curious to know? Alright then, let's begin. On September 14, 2015, two space and black hole detectors in Louisiana and Washington state detected a small signal, which turned out to be one of the universe's most astounding, powerful occurrences. These detectors witnessed two black holes colliding, both already out of control. But what are black holes? Well, in simple terms, a black hole is a region in space where gravity is immensely strong. The force of gravity is so strong that nothing can escape from it, not even particles or even electromagnetic radiation such as light. But who coined the term? Well, it was known as dark stars or frozen stars before physicist John Wheeler gave it a name, calling these black holes. Why? Because, well, nothing can escape from it. You probably already think of black holes as cosmic vacuum cleaners, but they are a little more sophisticated than that. According to Einstein's theory of gravity, sufficiently heavy objects change the curvature of the space around them, and gravity makes this warping visible to humans. Black holes are regions of space that can appear small or large in size. Though we are not fully aware of what actually happens when cosmic matter enters the black hole, we do know that this part of space right here is so twisted that anything that potentially moves towards it gets attracted to its center. Well, what will actually happen then if two black holes merge or collide with one another? This thought and question have been asked by many. In fact, scientists have found a way to detect when black holes merge, or in other cases when stars die, by using the Virgo detector and the Laser Interferometer Gravitational Wave Observatories, or LIGO. Renowned and well-known scientists like Imre Bardos, Sabine Hossenfelder, Oliver Jenrich, and Jillian Bellavary have provided us with the specifics of what would occur if this remarkable event were to take place in space today. According to famous scientists and members of the LIGO scientific collaboration, Imre Bardos stated that when two black holes are in close proximity to one another, they merge into a single, larger black hole. But we don't know exactly what this motion's exact cause is and how it brings two black holes together. The explanation of this cosmic process is still under research, but observing these collisions will, however, help in resolving a number of open questions, such as how black holes function as cosmic particle accelerators and whether Einstein's general theory of relativity is a reliable account of the physical world. Thus, as a result of this phenomenon, we somehow get the idea that the universe is still expanding. And here is what will actually happen. When two black holes merge, a new cosmic entity with a radius almost equal to the sum of the radii of the two original black holes is produced, giving the resultant black hole a significantly greater volume. The fusion mimics the encounter of two water droplets in outer space. Mass amounts of gravitational waves are emitted when the black holes get closer to one another. However, when this happens, a small fraction of their mass may undergo a transformation into pure energy and be emitted as gravitational waves. These gravitational waves can ripple through entire galaxies. So, is there a collision set on a course? According to a recent study, two supermassive black holes will collide in 10,000 years and cause reverberations throughout the cosmos. According to the New York Post, a team of astronomers from the California Institute of Technology discovered that the two supermassive black holes are orbiting each other every 2 years in deep space, about 9 billion light years away. Each supermassive black hole is thought to be hundreds of millions of times more massive than the Sun. The distance between the bodies is almost 50 times greater than the distance between Pluto and our Sun. The colossal collision between the two is anticipated to shock space and time when it occurs in about 10,000 years, spreading gravitational waves throughout the cosmos. Now, this was published in the Astrophysical Journal Letters and stated that a second known candidate for approaching supermassive black hole mergers was discovered. According to the study, the black holes seem to be coming close. This was made known by astronomer Tony Reedhead, a co-author of the study, along with his colleagues at the California Institute of Technology. Their study involved scanning the sky for galaxies with active black holes at their centers since 2008. They looked for holes with core jets that spew streams of matter at extraordinary speeds, particularly ones that are almost as fast as light and flood the cosmos with its light. Usually these very intense galactic centers are referred to as quasars, but Reidhead was searching for a particular kind of quasar called a blazar. In short, these jets from blazars would be directed toward Earth, and about 1,000 of these massive beams have actually been successful in monitoring for many years. But in 2020, something odd came to light. PKS 2131021, a black hole jet, was notable because it had a specific recurrence of light fluctuation. This light fluctuation is called a sinusoidal pattern, and it resembles waves that are moving up and down. According to Reidhead, the diagram showed that these patterns could actually be traced back to 1981 using the radio telescope data from potent devices like the National Radio Astronomy's Very Long Baseline Array. He stated that these patterns and wave consistency would have stopped in the 80s if astronomers and scientists hadn't persisted in knowing the true meaning behind the patterns. This was also made aware by Sandra O'Neill, a Caltech undergraduate student who picked up this project in 2021, which reads sine waves or sinusoidal patterns. But thanks to her, this lovely treasure would have been on the shelf and not on the internet now. But what did she discover? Well, O'Neill discovered that the pattern persisted until the 1970s and had a far higher degree of consistency at that time. In a statement, O'Neill stated, "We knew something extremely remarkable was going on when we recognized that the peaks and troughs of the light curve identified from recent periods matched the peaks and troughs reported between 1975 and 1983. Then came a renowned astronomer by the name of Roger Blandford, who then found the need to step in. Blandford used O'Neill's study and created a model of the sine wave and discovered that the pattern was caused by the motion of not one, but two black holes, even though only one produces the jet with a varying sinusoidal light pattern. Blandford also contributed to the understanding that the supermassive voids complete an orbit around one another every 2 years, or every 5 years when the universe's rate of expansion is taken into consideration. Nobody had realized that a binary with a relativistic jet would have a light curve that looked like this before, and Roger figured it out. The discovery of the binary black hole system in PKS 2131021 may be most notable for its potential to further research gravitational waves or ripples in the cosmos created by extremely powerful gravitational forces. As gravitational waves are a result of general relativity, which mind-bogglingly describes space-time, the ripples or gravitational waves were actually theorized by Albert Einstein a century ago, but their existence was long thought to be incontestable. But in 2016, that doubt was dispelled when researchers from LIGO reported that they had discovered such waves for the first time as a result of two black holes merging, which, as you would guess, produced a powerful gravitational pull. It shook the whole world. Finally, LIGO supported Einstein's interesting theory that space-time is a fabric that can be distorted by gravity in the same way that dropping a coin into a body of water causes ripples. Therefore, researchers need to identify sinusoidal light wave patterns produced by black hole jets for abysses bigger than a specific dimension. But for now, there isn't any black hole collision unless you stay for another 10,000 years. So let us know what your thoughts are in this in the comment section below, and if you enjoyed the content, leave a video like. You can also share this with your friends. Thank you for watching.